Trees are how you organize data when hierarchy matters. Today we'll cover what a tree actually is, the special case called a binary search tree that keeps everything sorted, where trees show up in real software, two classic operations in Python, inserting a value and traversing an order, and finally, when a tree beats a hash table. A tree is a hierarchical structure made of nodes connected by edges. The top node is called the root. Every other node has exactly one parent. Nodes with no children are called leaves. The depth of a tree is the longest path from the root down to any leaf. In a binary tree, each node has at most two children, conventionally called left and right. A binary search tree adds one rule: for every node, all values in its left subtree are smaller, and all values in its right subtree are larger. That single property is incredibly powerful. To find a value, you start at the root and at each step you compare, go left if smaller, right if larger. Each comparison cuts the search space roughly in half. That's O of log n. Trees are everywhere in software. Your file system is a tree. Folders contain files. The DOM in your browser is a tree of HTML elements. Database indexes use B trees, a generalization with many children per node. Compilers parse code into abstract syntax trees. Heaps for priority queues are trees in disguise. Even Git stores its history as a tree of commits. Inserting into a binary search tree is recursive and elegant. If the tree is empty, the new value becomes the root. Otherwise, compare with the current node, go left if smaller, right if larger. When you hit an empty spot, place the new node there. Average O of log n if the tree stays balanced, but O of n in the worst case if it degenerates into a chain. In order traversal visits the left subtree, then the current node, then the right subtree. On a binary search tree, this gives you all the values back in sorted order, for free. That's why BSTs are great when you need both fast lookup and the ability to iterate in order. Hash tables can't do that. Linear time, since you visit every node exactly once. When should you reach for a tree? Use one when you need data sorted with fast inserts and deletes, that's a balanced BST. Use one for range queries, like finding all values between x and y. Use one when your data is naturally hierarchical. Avoid trees if you only need lookup and don't care about order. A hash table is faster. And always prefers self-balancing variants in production. Trees are one of the most flexible data structures in software. Once you understand the basic shape, more advanced trees, AVL, red-black, B trees, tries, are all variations on the same theme. Next up, heaps. They're trees too, but with a different ordering rule that makes priority queues blazing fast.